Today we're going to talk about center shape, center, and spread. You should be writing or actually, well, at least underlining in your book your essential question, which is which measures of center and spread are appropriate for a normal distribution, which are appropriate for a skewed distribution. So we're going to talk about what all those vocabulary words look like. We're going to go through the two explore examples. You are going to have to pause it and read for a little bit and try some of the problems. That's the best way to do the lesson rather than just watching me do it for you. Today, our mathematical practice is reason, and basically we're trying to make sense of what the numbers and symbols represent in what we're talking about today. So we're going to talk about seeing the shape of distribution, and you can read along as I read it with you. Raw data values are simply presented in an unorganized list. On organizing data values by using frequency with which they occur in results is in a distribution of the data. So I'd probably organizing the data values by using the frequency with which they occur results in a distribution. A distribution may be represented as a frequency table or as a data display. Data displays for numerical data such as line plots, histograms, and box plots involve a number line. Well, the data displays for categorical data, so this was numerical data, categorical data such as bar graphs and circle graphs do not. Data displays reveal the shape of a distribution. So the table, it gives data of a random sample of 20 babies born at a hospital. We are supposed to make a line plot for the distribution of births. This is something you probably did in Algebra 1. So we're going to start with looking at the birth months. So we're going to look at all these values here and all these values here, and we have to get them all on this line. So all we're going to do is we're going to start with birth month 5, and I'm going to make an X. And then birth month 7, I'm going to make an X. And 11, and hopefully you're getting the idea. We're going to keep making X's. 2. I'm crossing them off so I'm not forgetting what I've done. Might need to go back to them later, but at least I'm kind of keeping track of it somehow. I could put a check mark next to it. 10, 3, 1, 4, 7. Oh, notice I have to stack an X on top because we're trying to get a picture of what it looks like. 6, 9, 10, 11, 1, 6, 5, 8, 9, 12, and 2. So it's fairly evenly spread out, it looks like. Okay, so now we're supposed to do one for the birth weights and one for the mother's ages. So my suggestion is that you go ahead and pause the video and try those two and then start the video again to look at the answer. All right, I'm going to go ahead and go through the line plot for the birth, or the plot distribution for the birth weight. So this time, instead of crossing out, I'm going to use a check marks because I might need to come back to this data later. So I've got 3.3. So 3.3 gets an X. 3.6. 3.5. 3.4. 3.7. 3.4. 3.5. 3.2. 3.6. 3.4. 3.6, 3.5, 3.4, 3.7, 3.5, 3.8, 3.5, 3.6, 3.3, and 3.5. So interesting, the data looks much different than it did on the last one. It looks like it's all gathered in the center a little bit. Okay, let's look at the mother's ages now. Okay, so the first one is 28, 31, 33, 35, 39, 30, 29, 30, 31, 32, 33, 29, 31, 29, 34, 30, 32, 30, 29, 28. And again, this one looks like it's all kind of gathered down here at this end and not much is going on towards the higher end of this graph. So as I was going through these, I kind of gave you some clues. You need to pause the video and I need you to do a reflection on 1, 2, and 3. And each of them, you're describing what the distribution of the data looks like. So pause the video and take a few minutes and write those in some nice sentences. All right, so hopefully you notice now in these pictures here that we've got some actual names for the way that that data was written, or that data picture that we saw in the last one. So let's read through this here in the definitions. As you saw in the previous Explorer, data distributions can have various shapes. Some of these shapes are given names and statistics. A distribution whose shape is basically level is called a uniform distribution. So like the first one that we saw was pretty uniform. A distribution that is mounded in the middle, so it's mounded in the middle with symmetric tails at each end, that is, it looks like the bell shape, is called the normal distribution. They used to call it the bell curve. A distribution that is mounded but not symmetric because one tail is longer than other, so mounded but not symmetric, is a skewed distribution. When the longer tail is on the left, it is said to be skewed left. When the longer tail is on the right, it's said to be skewed right. The figures show the general shapes of a normal and skewed distribution. So skewed left, symmetric, which is the normal, and skewed right. Shape is one way of characterizing a data distribution. Another way is by identifying the distribution's center and spread. You should already be familiar with the following measures of center and spread. So mean, we've already seen that a few times. And you take all the numbers, you add them up, and then you divide by the total number of numbers. We've also seen median, which is when you write the numbers in order, you get the middle number. Okay, so those are both talking about the distribution's center. And then there's standard deviation. We calculated that the other day. That talks about some of the spread of the data. And then there's something called interquartile range. So this basically gets you, notice it says, well, let's read through this one. Or IQR of data values written in ascending order is the difference between the median of the upper half of the data, called the third quartile, or the median of the lower half of the data, called the first quartile. So again, it's a measurement of spread. And what it does is it takes like the 50% in the middle and it makes it so you're just looking at that data. It basically kicks out outlier data where standard deviation does not. So if you have some like massive outliers, it's good to use this calculation. So to calculate it, you take the third quartile, the median of the third quartile, and subtract the median of the first quartile. We're not going to do that calculation by hand. We're going to use Desmos to help us out today. So some other notation stuff to distinguish the population mean from the sample mean. Statisticians use the Greek letter mu. So this is the population mean versus, oops, I got too close to the top. Population versus this is the standard mean, the X bar that we talked about the other day. Similarly, they use the Greek letter sigma. This one is the population mean, instead of S to distinguish the standard deviation from sample standard deviation. So this one's the sample standard deviation. We will work with population for this, and usually standard for that one. All right, so we're supposed to use the calculator to compute the measures of center and the measures of spread of distribution of the baby weights and the distribution of mothers' ages from the previous Explorer. Begin by entering the two sets of data into the lists on the graphing calculator as shown. So we're just going to go ahead and do that in Desmos. So get into Desmos, and remember you're going to do a plus sign and a table. And let me see what they have it as. Calculate. They want us to do the two sets of data as shown. Baby weight and mother's age. Distribution for the baby weight and mother's age. So we're going to make x sub 1 the baby weight and x sub 2 the mother's age. Okay, so we're going to go 3.3. I'm just going to go through the data, and I'm going to go down, and then I'll go back and do the other one. 3.6, 3.5, 3.4. And the nice thing about doing this in here is we can go back and look. 3.7, see if we made a mistake. 3.4, 3.5, 3.2, 3.6, 3.4, 3.6, 3.5, 3.4, 3.7, 3.5, 3.8, 3.5, 3.6, 3.3, and 3.5. All right, hopefully I got them all. I'm going to count really quick. Let's see. I should have 20 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Perfect. Okay. So if you haven't paused the video to get into Desmos, pause the video, get into Desmos, get those numbers in, and then in Y1 also put the mother's age. So I'm going to do that, and you should hopefully get into Desmos, okay, and do that yourself. 3, 29, 30, 31, 32, 29, 31, 29, 34, 30, 32, 30, 29, 28. Perfect. Okay, so I've got all my data in there. One is in X1 and one is in Y1, and we can use both lists, so you can probably add more there and make more lists and a bigger table if we needed to. Okay, so let's go back to the presentation here and see what they want us to do next. We got the data in. So now it says we're supposed to calculate the one variable statistics for the distribution of mothers' ages. Record the statistics listed below. I don't know why they did mothers' ages. I thought they did both. Oh, I missed something in the first one. Let's see. We're supposed to do it for baby weights and mother's ages, and I just don't have the baby weights in the presentation. So we're going to do the baby weights. Okay. And we'll find the X bar, and this is probably in your notes. We will find the median. We will find the popular, they're saying sample, but they wanted us to do population. I don't know why they're using the funky notation. I think it should be that notation, because there's a note in the book that says that we should be using the population. And then they want us to do the IQR. All right, so let me show you how to do each one of those. And then we will do, you can do the next one on your own and you can check it against mine. Okay, so I'm going back to Desmos and I have my data in there. So I'm going to start with the mean. We talked about that one last week. So mean and then parentheses, and then our data is in the table in X1. So you do X, you hold down the underscore and 1. And there it is. It's a 3.5. So I'm going to record that here. So it was 3.5. Okay. Now I'm going to do the same thing, and I'm going to find the median. So, and I'm going to go ahead and just keep my data there. So I'm going to go median. And I'm going to say x sub 1. And it says my median is also 3.5. So let me get back there and here, and I got it right, 3.5. All right, now we're going to do the population standard deviation, which again, we calculated the other day in class. So you're going to do ST for standard, DEV for deviation, and then we're going to do P for population in the same pattern, X sub 1. And there it is. It's 0.145. So 0.145. I like 3 decimal places, so we're going to go 3 decimal places. So we need that for AP Calc. 0.145. Okay. Now the next one's a little bit trickier. There's interquartile range. We're going to do a calculation in there. In the whole line, we're going to do a couple things. So if you have to type in quartile is the calculation, and then you have to tell it what list, so X sub 1. And then notice I was down low, right? It was down here. Then I pushed the arrow to get it up high again, and I do a comma. And then you have to tell it it's the third quartile minus the first quartile. So you do a 3. And then I'm going to subtract, and I'm going to type in quartile again. X sub 1, get out up so I can do a comma, 1. And there's my calculation. It's 0.2. Here. All right, 0.2. Okay. So now what you should do is you should do the mother's birth. So pause, or mother's age at birth. So you should pause the video, do the calculations using Desmos. Instead of using X sub 1, you're going to use Y sub 1. Turn the video back on and I'll do it with you. All right, I'm going to go ahead and calculate our data again. So I'm going to do the mean again. So mean, I'm going to do Y sub 1 because it was a different list. And so for this time I got 31.15 for my mean. So I'm going to put that in here. 31.15. Okay, then I'm going to do my median, which is X sub 1 again. And it is 3.5. Oh, not X sub 1. Sorry, Y sub 1. Should be getting a different number. 30.5, that's much better. So 30.5. 30.5. Then we're going to do standard deviation population for Y, column Y sub 1. And we get 2.613. 2.613. 2.613. And then we got to do our interquartile, or IQR. So we're going to do quartile. And we're going to do Y sub 1, comma 3. Oops, I got it in the wrong spot. Comma 3, parentheses, minus quartile, Y sub 1, comma 1. So 3.5. Let me find my thing. So 3.5. All right, and that's it for our calculations. All right, so what you need to do on your own is you need to go through these 3 reflect questions and make sure that those are filled out, because when I grade you, I'm going to grade those in your notes. So you need to do some thinking about what we've done and see if you can do some observations from the work that we have done there. Okay, and then that's it for the lesson today.